Hello my dear students, welcome to AriserTalent. I'm your maths teacher Arpita Sharma, and students, what we were studying was chapter triangle. Okay, so starting with writing the name here, our chapter 6, that's triangle. Right students? Okay. So, we were discussing some theorems, and we were having two equiangular triangle and we have to prove this and that, and in that chain we are having this question here. This theorem here, if two triangles are equiangular, prove that the ratio of the corresponding sides is same as the ratio of the corresponding altitudes. Okay, so we will just first draw what's saying. Let's draw this. If two triangles are equiangular, so it's just first draw two triangles, two big triangles here, and let's draw one similar triangle here or triangle here. Let's say a triangle here. Now name it like A, B and C, and name it like D, E and F. We do this now. Okay. Now it's saying that prove that ratios of the corresponding sides is same as the ratio of the corresponding altitudes. So if I am taking an altitude here, this is not altitude. What I am done? Okay. So I am drawing an altitude here from A to BC. Okay, let's call it what? M. Okay, and let's call it what? N. Right. Now it's saying that you have to prove that the ratios of the corresponding sides, these are the corresponding sides, is same as the ratios of the corresponding altitudes. Altitudes are this AM and DN. So we have to prove that ratio of these altitude, that is AM by DN, is equals to what? We have to prove this, right? That the ratio of the corresponding sides. Now the corresponding sides are BC and EF, BC and E and F. This is what we have to prove. So we will walk with the starting, and this is what we are having. So given that triangle A, B and C is equals, no, not equals, is similar. Is similar to triangle DEF. Now by applying by Thales theorem, what we can write, that AB by D equals to BC by EF, right, and equals to CA by FD. Now mark it equation 1. We are going to use it further. Now it's also saying that this is altitude. So this is angle 90, this is angle 90, this is altitude. That's why this is angle 90 and this is angle 90. Now if we look closer to these two little triangles, this is ABM and DEN. What we are having? No, we have to prove AM by DN. So it's, it's our requirement. We should have something AM and DN in our equation. So for our sake, we have to do this. Okay, we have to take triangles in which we are having these sides common. So we are taking this in triangle what? ABM and triangle DEN. You will see that AMC and angle DNE is equals to what? 90 degrees. So, both are 90 degrees, so both are equal. So, we can say that angle B is equals to angle E, which is by similarity. You can also say it, that is given, and what? Angle A is equals to what? Angle D, that's EDN, and that's, you can say, the complete angle is what? BM. And why? These are equals to 90 degree. You can say that given altitudes, okay, right. Now we are having angle B and angle A equals, these two angles equal, this angle is equal this, and this angle is equals this. So, by angle similarity, I have told you, by angle similarity, these two triangles are what? Similar. So, just write it, by angle similarity, you have what? Triangle ABM is similar to triangle DEN. Right, students. So, by applying again Thales theorem to these two particular triangles, I haven't written something here, AB and M, na? Okay. So, AB and M. Okay. Now, I can write that by Thales theorem, Thales proportionality theorem, or you can say, I am going to write it short. Okay. What we are having? AB by DE will be equals to what? BM by EN will be equals to what? AM by DN. Right, students? Now, this is equation second. Now, we have to pick the things of our use, and the things are AM by DN. Now, look here, AM by DN is here, AM by DN is here, and BC by EF. Now, BC by EF. Okay. So, this is the different thing, and this is the different thing. If we are having any common proportion in that, then we can say by first and second we have proven this. Now, look at this, AG by D, and here AG by D. So, this proportion is equals to this proportion. Okay. So, what we can say? Then any two proportions from here, from these two equations are equal in each other. So, we can easily say that by equation 1 and 2, what we are having is actually BC by EF is equals to nothing but AM by DN. Right, students? So, isn't it what we have to prove? BC by EF this side and AM by DN this side. So, we have done a great job, we have proved it. Okay, so what you have to do it? Copy it. And let's move. Then move to the another theorem. We have a lot of theorems here. Okay. So, assuming that you have noted, we are moving to the next theorem. Okay, students. These theorems are fascinating, na? If this equals to this, then this equals to this, and then this equals to this. Okay. So, what is next? We should have a look. Theorem 4. If one angle of a triangle is equals to one angle of another triangle, and the bisectors of these equal angles divide the opposite side in the same ratio, prove that the triangles are similar. Okay. So, as we always do, we always draw triangle. So, we will do the same here, and what we will write? Say, write A, B, C, D, E, F, and we will prove that we all know the alphabets. Okay, students, so if one angle of a triangle, is equals to one angle of another triangle. So, let us say that we are having this angle equals to this angle equals to angle D, and the bisectors of these equal angles divide the opposite side, bisector of these. Okay. So, bisector of these triangles I have drawn, and I will name it what? What I am having, XY or PQ or MN. Okay, so I will go with the PQ. The bisectors of these equal angles divide the opposite side in the same ratio. Okay, so prove that the triangles are similar. I haven't given that these two triangles are similar. I have just given that this is a triangle, this is a triangle. Now, this angle A is equals to what? This angle A is equals to angle D, right? I have given this. Then, the bisector of these equal angles divide the opposite side in the same ratio. So, ratio BP by PC. So, if this is dividing this side in this ratio BP by PC, then that will be equals to what? EQ by QF. Okay. Now, I have also given that we are having these angles equals this BAP and PAC is equals to what? 1 by 2 of angle A, and again this is also 1 by 2 of angle A because angle A and angle D are equal. So, ultimately we have given that half angle A equals to half angle D is equals to what? Angle BAP equals to what? Angle EDQ. Right, students? We have given this information. Okay, so it's all given here, and we have to prove what? That this angle and this angle are similar triangles. Now, let's read it out again and find that if we are if we have missing anything. If one angle of a triangle is equals to the one angle of another triangle, and the bisectors of these equal angles divides the opposite side in the same ratio, prove that the triangles are similar. Right, we haven't missing anything. So, we have to prove that these, either we can prove that two angles are similar in this and this, then we can prove that ABC and the DEF are, you know what, similar to each other. So, if we have BP by PC and EQ by DF. Okay. So, in triangle what? APB, ABP and triangle DEQ. Okay, what we are having in these two triangle, angle BAP and angle EDQ are what? Equal. These two angles are equal, right? Now, we are having BP by PC equals to EQ by QF. Okay. So, we can write it like half, I will write it again, but BP by PC equals to EQ by QF equals to what? Half of BC by half of QF. Okay students, now we have given that this angle A is bisector, this AP is bisector, this, now we have given this angle A is bisector, this AP is a bisector of this PB and PC. So, what we will be having from our previous theorem, AP is bisector, angular bisector, okay. This will imply what? AB by AC, the sides which are making that angle will be equals to what? The ratio of this side BP by PC. Now this is, you call it second equation. Again DQ is angular bisector, okay students. So what will be you having here is DE by DF equals to what? EQ by QF. Now this is third. Okay, so we are having these three equations. Now we have to prove that a triangle is similar. So if triangle is similar, then we will be having our one angle is equal, we are having one angle is equal. Now if we have the proportion of two sides equal, then we will be having this property side angle side, and by this property we can prove that the angles are that the triangles are similar. Okay, so AB and AC are here, AB and AC is here, and DE and EF is here, DE and DF is here. Now if you look at equation 1, 2 and 3, here you are having EQ by QF and here you are having EQ by QF. So here you are having BP by PC and here you are having BP by PC. So we can say by equation 1, 2 and 3 that these all the 6 proportions are what? Equal to each other. So by first, second and third I can write what? That AB by AC, which is this, and I am wanting this DE by DF, DE by DF. Okay, so by equation 1, 2 and 3 we are having what? AB by AC equals to DE by DF, right students? Now this can again be written as AB as it is here, AB as it is here and DE here, right, will be equals to what? AC here and by DF here. Now we are having proportions AB by DE and AC by DF here. So I can write that proportion of these two is equals to proportion of these two, and this angle is this angle, okay, and angle A equals to angle D. So what we are having that the angles are equal and also the sides corresponding to these angles are also equal. So by side angle side property, what we can say? write it here. By equation fourth, applying side angle, side property, similarity, we have what? Triangle ABC similar to triangle DEF. Okay, students. So, this similar to this, note it. Okay, students. So, moving forward, mostly we are having same categories questions here, because we are having one remaining question on remaining theorem on this particular pattern, and after that we will be starting question based on area. We have to prove area things, right? You know na, what is the area of triangle? That is half base by height. Okay, so theorem 5, if two sides and a median bisecting one of these sides of a triangle are respectively proportional to the two sides and the corresponding median of another triangle, then the triangles are similar. So, looking something confusing. Okay, so first draw two triangles to make it more easy. It is easy indeed, you will get to know. That is A, B and C, and that is D, E, F. So, I have made two triangles. Now, it is saying that if two sides of a median and a median bisecting one of these sides. So, I am having two sides, this side and this side, this side and this side, and a median bisecting one of these sides. So, let us have this and this like P and Q. These are the medians. Medians, that means BP equals to PC and EQ equals to QF. So, and the median bisecting these lines are respectively proportional to the two sides and the corresponding median of another triangle. Same is given in another triangle, then the triangles are similar. So, now what you have given, that you are having these two sides, okay, this side and this side and this side. Now, proportion of this will be AB by D will be equals to BC by EF will be equals to the corresponding medians proportion, that is AP and DQ. So, what you have given, I have to write it here, given that AB by D equals to BC by DF, no, it is EF, equals to AP by DQ. Let us mark this equation 1. Now, students, look this very carefully, that it is saying that two sides and the median bisecting one of these sides, one of these two sides, okay, it is given. You can't do this that you have started having median of this side, no, because one of these, so you can either select this as or this. So, I am selecting this base. Now, exactly same here, okay, this is given. Now, let us see what we have to do. We have this proportion, so we have to somehow use like this only, and we have to prove that triangle ABC similar to triangle DE and F. Now PQ is of no use, PQ and DQ is of no use, but we have to use it somehow so that we can prove this relationship. So can I write AB by D equals to, BC can be written as half of BP, okay, half of BP by half of this EF can be written as half of EQ equals to AP by DQ. Now, if you will see the equation second carefully, that is, this will cancel out half and half. AB by DE equals to BP by EQ equals to AP by DQ. So, look, this by this equals to this by this equals to this by this. So, by converse of Thales theorem, can you say that these two triangles are similar or not? You can say this, na, these are similar. So, just write it. Triangle A, B and P is similar to triangle D, E and Q. Now, if these two triangles are similar, so I can say that this and this are equal, angle B and angle equal. Okay, I can say this implies that angle ABC is equals to angle DEQ. So, what I have proven that this angle is equals to this angle, right students? I have proven this angle is equals to this angle. Now, if somehow I prove that these two sides are having the same proportions, so I can make sense, I can prove that this triangle is equals to the, this triangle similar to the, this triangle. Okay. So, AB, I have to prove that AB by BC. Now, I am having any AB here, I am having AB here and BC here, and D, I am having DE here, and EF, I am having EF here. By equation 1, AB by DE is equals to BC by EF. Okay. So, I can rewrite it as AB by BC. No, I don't have to rewrite it again. AB by DE is equals to BC by EF. Okay, I am having this and I am having this common angle, this angle made from these two sides ratio is also equal. So, by third and fourth, by third and fourth and what? Side angle side similarity, we have what? Triangle ABC similar to triangle DEF, isn't it? Right students? Okay students. So, note this. Okay. I am rubbing this as student. Now, our next question is Theorem 6, which is if two sides and a median bisecting the third side of a triangle are respectively proportional to the corresponding sides and the median of another triangle, then the two triangles are similar. Okay students, so we are having this next theorem and after that we will be having some theorems on similar triangle and area of similar triangle. Okay, we will be having these two theorems discussing, and this theorem 6 discussing in our next lecture. Okay students, then do something that try to solve this theorem and keep watching. Thank you.